Today our topic is RC coupled amplifier. So what do you mean by amplifier? So amplifier or amplification is the process of strengthening the weak signal without any change in the general shape of the signal, that is without distortion. We call it as amplification. Repeat. So amplification is the process of strengthening the weak signal without any change in the general shape of the signal, that is without distortion. That is called amplification. Okay. For example, we take amplifier circuit. This is amplifier. So amplifier consists of gain. Some AV denoted by AV is equal to 100 millivolts. So this is the amplifier input. This is the amplifier output. For example, amplifier input is 10 millivolts signal. 10 millivolts. So what is the output of amplifier circuit? So here amplifier gain is 100 millivolts. 100 into 10, 1000 millivolts. So that means amplifier is strengthening the 10 millivolts weak signal into 1000 millivolts signal, strong signal. That is the purpose of amplification. So amplification is the process of increasing the weak signal strength by increasing the amplitude of a given signal without changing its characteristics, without distortion. That means, so the input signal may be a current signal, voltage signal, or power signal. Okay, that is the meaning of amplifier. So an amplifier which is completely based on a transistor is basically known as a transistor amplifier. So we know that transistor can be used as a switch and also amplifier. So transistor can be used as an amplifier in which region? It is in active region. So in active region, transistor can be used as an amplifier. So the input signal may be a current signal, voltage signal, or power signal. An amplifier will amplify the signal without changing its characteristics, and the output will be modified version of the input signal. That means we have to enhancement from input to output. So applications of amplifiers are wide range. So they are mainly used in audio, video, and communications and controls. So many applications are there for amplifiers. Okay. So first we will see the single stage emitter amplifier. So why it is emitter amplifier means, so emitter is connected to ground. So this configuration is common emitter amplifier. But here RC means resistance and capacitance. RC means resistance and capacitance. So RC coupled means resistance, capacitance, coupled amplifier. So in single stage emitter, RC coupled amplifier is a simple and elementary amplifier circuit. This is the basic circuit. So what is the main purpose of this circuit is pre-amplification, that is to make weak signal to be stronger enough for further applications. So it is designed properly. This RC coupled amplifier can provide excellent signal characteristics. So we will describe this one. So this figure consists of one transistor. This is one transistor which is having three terminals. One is base, emitter, collector, and also we are having R1 resistance, R2 resistance, and RE resistance and RC resistance. So here capacitors also there. One is C1 capacitance and CE capacitance and C2 capacitance, and VCC. VCC means DC voltage. So here VI means this is the input. We are giving input signal, small input signal. We have to amplify into some weak signal. So amplitude or strength of the signal is very high at the output of the amplifier or RC coupled amplifier. So this is the description of circuit. Okay, here you can observe R1, R2 is the resistance. So this is the RC coupled means in our circuit consists of only three components. One is R, C and transistor. R, C and transistor, that's why it is a RC coupled amplifier. See here VCC, this VCC provides biasing to input side and output side. So this R1 provides the biasing to the input side. R2 provides stabilization. R2 provides stabilization and RE also provides stabilization. So what about C? So this C1 we also call it as base capacitance or input capacitance. What about CE? CE capacitance means emitter capacitance or bypass. This one we call it as bypass capacitance. Bypass capacitance. This C2 we call it as coupling capacitance. C2 we call it as coupling capacitance. So this is the description of RC coupled amplifier circuit in single stage. We have connected many stages like this. So this is single stage. Now we will connect here output of the first stage. We will connect some other RC coupled amplifier. Output of the next stage we will connect some other type of RC coupled amplifier, so that we will increase the signal strength step by step. So here signal strength means 20 volts, 20 millivolts means next stage we will get 30 millivolts. Next stage we will get 40 millivolts. Like that we have to increase the gain of the amplifier. For that purpose we use multi-stage RC coupled amplifiers. So this is the description of single stage common emitter amplifier. So the circuit explanation already I discussed. So capacitor C at the input acts as a filter which is used to block DC and allows AC only. We know the formula. What is the reactance of capacitance? So reactance of capacitance is denoted by Xc is equal to 1 by 2 pi Fc. 1 by 2 pi Fc. So why capacitor act as a it blocks DC and allows AC? Already I told. So this is the reactance of capacitor. If frequency is equal to 0 for DC, frequency is equal to 0. If you will substitute F is equal to 0 means 1 by 2 pi into 0. So 1 by 0 is equal to infinity. Infinity means open circuit. That means it blocks. So capacitor blocks DC and allows AC. So that is the meaning. Okay. So R1, R2 resistors are used to provide the proper biasing to the transistor, and R1, R2 form a biasing network which provides bias voltage to drive the transistor in active region. That means, so this R1 resistance and R2 resistance we seen in biasing circuit. Because of R1, R2 we will get this voltage, this node, we call it as V2, we will get biased voltage. This biased voltage can drive the transistor into on stage. That is the meaning. So how to find the bias voltage here V2? So V2 is equal to basic formula. Voltage is equal to current into resistance. Current into resistance means across R2. So what is current? Current is equal to here VCC by total resistance R1 plus R2 into this R2. So total VCC by R1 R2 into output. This is called voltage at this node. So this biased voltage can drive the transistor. Okay, the region between cutoff and saturation region is known as active region. The region where the bipolar transistor operation is completely switched off is known as cutoff region, and the region where the transistor is completely switched on is known as saturation region. We know that transistor can be operated in different modes. One is saturation region, cutoff region, active region, and inverse active region. Okay, so transistor can be used as active region means so first junction is forward bias and second junction is reverse bias. If it is a cutoff region means first junction is reverse bias and second junction is reverse bias. Like that we will seen already. Okay, transistors or resistors RC, RE are used to drop the voltages of VCC. Resistor RC are a collector resistor and RE is the emitter resistors. Both are selected in such a way that both should drop VCC voltage by 50% in the above circuit. Okay, the emitter capacitor CE and emitter resistance RE makes a negative feedback for making the circuit operation is more stable. Here in this circuit, whenever signal is given, a AC signal, some DC components are also there. So this first capacitor blocks the DC component and it allows the AC component. That's why this base capacitor we also called as blocking capacitor. This base capacitor we also called as blocking capacitor. So it blocks the DC and allows the AC to the transistor. So that is called single stage amplifier. So we go for multi-stage or second stage amplifier. So we can observe, so first stage up to now this dotted line up to now left hand side is the first stage and right hand side is the second stage. So this R1 R2 provides a biasing voltage here to drive the transistor Q1, and C1 or CA is the blocking capacitor and CE is the bypass capacitor and RC is the collector capacitor. So these all capacitors at low frequency act as a high reactance. So there is no signals are passed at low frequency. That's why gain is very less in low frequencies. Similarly, so this is the input. VA is the input. This is the signal, input signal. So this is a less voltage, less amplitude. We have to enhance this amplitude without changing the shape of the signal. Okay. Here, so first stage output. So CC is the coupling capacitor. We will get output of the first stage is this one. So here we are not changed the shape, only we have changed the phase. See here, this is the signal. Here phase is changed from positive to negative. So 180 degrees phase shift for CE amplifier. Again we have to get same phase means again we have to add second stage. So in second stage we will get whatever input is given, that is appears at the second stage of RC coupled amplifier with high gain. So output, this is the output of second stage RC coupled amplifier. Okay, we are keep on connecting different stages. What happens? Gain is increases. Okay, it keep on increases first stage, second stage, and third stage. So gain is increases. So one important point that has to be noted here, total gain is less than the product of the gains of individual stages. So for example, here two stages are there. So total gain is, for example, 20. Total gain is, for example, 20 volts or 20 millivolts. Okay. So the product of individual gains is less than 20 volts. So total gain is less than the product of individual stages. For example, here this is the 2 millivolts. This is the 2 millivolts. 2 millivolts. So 2 into 2 is 4 millivolts. So 4 millivolts is less than 20 millivolts. So this is right or wrong? So total gain is less than the product of the individual stages. So here total gain is greater than. So this is wrong. So individual gains, for example, we will take 10 millivolts into 10 millivolts. First stage 10 millivolts and second stage 10 millivolts. So 10 into 10, 20 millivolts. So 20 millivolts is greater than or equal to 20 millivolts. So this is correct. So finally what I say that total gain is less than the product of the gains of individual stages. Total gain is less than the product of gains of individual stages. Okay. So this is the frequency response curve of RC coupled amplifier. Okay, frequency response curve. So it is a curve between frequency and voltage gain. It is a curve between frequency and voltage gain. You can observe, see this is the 50 Hz. This is the 50 Hz. This is the 50 Hz. We call it as F1. This is 20 kilohertz. We call it as F2. What is the bandwidth of this curve? So bandwidth is equal to F2 highest frequency minus lowest frequency. So why this type of curve occurs, we will discuss now. Why this type of flat region in middle? Why low frequency is roll off or decreases? Why it is high frequency roll off or decreases? We will see. So it is a RC coupled amplifier. So RC coupled amplifier, we have three capacitance. One is blocking capacitance CB, and other one is emitter capacitance, and third one is collector capacitance or coupling capacitance. So this is blocking capacitance, it blocks DC. This is bypass capacitance. These are different names, bypass, because if signals are bypassed to the ground, DC signals. Next one is CC, coupling capacitance means we have to connect the output of first stage into second stage. That is called coupling capacitance. So we know that these capacitance reactance is depends on Xc is equal to 1 by 2 pi Fc. So this range from 0 to 50 Hz we call it as low frequency range. So low frequency range, why this curve is roll off or decreases, why gain is very less at low frequency means, low frequency means here F is equal to very low means, so denominator term is very low means, what about Xc, reactance of capacitance is very high. Reactance of the capacitance is very high, so the gain is roll off. So at low frequency gain is roll off because reactance is more. Similarly, here from this 20 kilohertz to from more than 20 kilohertz, here also gain is roll off or decrease because here reactance of capacitance is high. Here reactance of capacitance is low, very low. Because of reactance of capacitance is very low, some loading effect will occur at the output side. Because of loading effect, we get this curve is roll off or decreases. So in between 50 kilohertz to 20 kilohertz, we got flat region. So flat region, this region is required region. So transistor can be used as an amplifier, this flat region. Okay. So this is the frequency response curve of RC coupled amplifier between frequency versus voltage gain. Okay. So gain can be measured in dB. Only this dB. We can't use this type of dB. This is wrong. And this type of dB. This is wrong. And this type of dB. This is wrong. So gain can be always represented in decibels. Gain can be always represented in decibels. So this is called RC coupled amplifier. So the advantage of RC coupled amplifier, first one is cheap, economical and compact. It uses only resistors and capacitors. So it is very cheap. So resistors and capacitors, we will pay 5 rupees, we will get 5 resistors and 5 capacitors. So based on capacitors and resistors, we will make it as RC coupled circuit. So it is very cheap economically. So it offers a constant gain over a wide frequency band. So this is the constant gain. So this is the constant gain over a wide range of frequency. This is the wide range from 50 Hz to 20 kilohertz. We will get constant frequency band. So the disadvantages of RC coupled amplifiers are, first one is unstable for low frequency amplification. We know that. See, for low frequency we can't use. This is a unstable or very distortion. The distortion is more at low frequency and also distortion is more at high frequency. It is a distortion free. There is no distortion at the flat region. So distortion free, we also call it distortion free or distortion less. So at low voltage, power gain as the effective load resistance is reduced due to the fact that the input of each stage presents at a low resistance to its next stage. So that is called loading effect. So moisture sensitive, making them noisy as time elapsed. So full impedance matching, as it has the output impedance several times larger than the device and its N terminal. For example, a speaker in the case of public address system. So here impedance matching problem will occur because we are adding a number of stages. Some loading effect will occur. Because of loading effect, we have to mismatch the next stage of RC coupled amplifier. So loading effect will occur in RC coupled amplifier. Next one is narrow bandwidth when compared to JFET amplifier. We will see next JFET in detail. So what are the applications of RC coupled amplifiers? So RF communications. What do you mean by RF? Radio frequency communications. We will use RC coupled amplifier because it uses set of frequency range. We see just so this is the frequency range 50 Hz to 20 kilohertz. We will use properly this one. Very less frequency range and a very high frequency range not. So a set of bands we will use in this RC coupled amplifier. Next one is optical fiber communications. Public address system as free amplifiers. Pre-emphasis. So we are enhancement of signals in amplifier circuits. Next, controllers and radio or TV receivers as small signal amplifiers. We will use this RC coupled amplifiers because it is very simple circuit and frequency response is also good at band of frequencies. Okay. So today I will summarize what we discussed to now this session. So RC coupled amplifier we discussed today. So RC coupled means resistor capacitor coupling. We call it as RC coupled amplifier. So RC coupled amplifier is consists of only resistance and capacitance and transistor. That's it. Only three components: resistance, capacitance, and transistor. So the circuit here. So this is transistor. So I draw this one. So this is RA resistance. This is RC resistance. So this is R1. This is R1. This is R2. So this is resistance CB or blocking capacitor. So this is VN. So this is VCC, means DC voltage, and this one is emitter or bypass capacitor. This one we are taking output. So this is the output. So this is the RC coupled amplifier. So this VCC is for biasing both input and output VCC. Next R1. So R1 is used for biasing the input side. R2 is vary the Q point. This RE is stabilization of Q point. So this RE is for stabilization of Q point, RE also. So this is CB. CB means blocking capacitor. So whenever input is given, it blocks the DC and it allows the AC signal. So because of R1 R2 voltage divider, we will get voltage V2 voltage divider voltage. So because of this voltage, this transistor can drive into on state. So this is CC. CC means coupling capacitor of the next stage. We will connect some other RC circuit by using this capacitor. So this is the, and also we see frequency response curve, frequency versus voltage gain. Up to low frequency, three stages: low frequency, medium frequency, and high frequency. At low frequency, capacitor reactance is very high, so that the curve or voltage gain is not stable. At high frequency also, capacitance of reactance, even though it is low, because of loading effect, that voltage gain is varying. So only between range of frequencies, that voltage gain is very flat. So this is called RC coupled amplifier. Okay, with this we completed our second unit syllabus. Next we will see the third unit, that is FET. That means field effect transistor. We will see in next session. Okay. Okay, thank you.